Expand these brackets up to x cubed, give the range. So let's have a look at this then. There's a 2 here that we'd want to take out the bracket. When we take it out, we'll need a 3 over 2, won't we, in the bracket? And then we'll have 2 to the minus 1. So basically I'm going to take that in one fell swoop. But what's left in the bracket now will be 1 minus the 3x over 2. It's minus 1. So I did 2 steps in one there, and I hope you can see that. And then I'm going to do the same with the 3. So let's take the 3 out of the bracket and then use properties of indices to write that as 3 to the minus 1. And then we've got 1 plus 2x, but it's over 3, isn't it? So it's plus 2x over 3, and that will be to the minus 1. So that's what we've got then, which is equal to 1 over 6 times these two brackets. 1 minus 3x over 2 to the minus 1, and it's 1 plus 2x over 3. So minus 1. Now we just expand these brackets. So that's equal to 1 over 6 times 1 plus 1 over 1 minus x. This is our input x. This is just 1 over. So 1 over 1 minus this is just the 1 plus x series, isn't it? So 1 plus, but our x in question is 3x over 2. Plus the input x squared, which will be 9x squared over 4, won't it? And then the input x cubed is 27x cubed over 8. So that's what happens when you expand those terms. The other one will be the alternating sign series for binomial series, won't it? Binomial expansion. So we get 1 minus the x, the input x, and then we plus the input x squared, so that'll be 4x squared over 9. And then minus the input x cubed, 8x cubed over 27. And plus dot dot dot. So there's our series then. So it's equal to 1/6. Now what have we got? We've got one of all these, so let's write that down. Over 3 plus 4x squared over 9 minus 8x cubed over 27. So one of those, and all of those can be included up to x cubed. Then 3x over 2 times all of these. So 3x over 2 times 1 is 3x over 2. And then the next term will be minus. It will be x squared, but it will be 3 over 2 times 2/3 is just 1. So it's minus x squared. Then we've got the cubic term. So that's 3/4 of 12. 12 over 18 x cubed plus 12 over 18, which is 2/3 x cubed minus and so on. So that's that one. So that was multiplying through by that term. Now we do the 9x squared over 4. So that'll be plus 9x squared over 4. And then we've got minus 18 over 12, isn't it? X cubed minus 18 over 12 is 3 over 2 x cubed. And then the last thing we need to worry about now, and that will be plus dot dot dot. And then we've got the cubic term. When we run that through, we'll just have 27 over 8x cubed plus 27 over 8, lots of x cubed. There's our series then. So what have we got here? We've got 1/6 of, we've got 1, then we've got 2/3 plus 3 over 2 sixths we need, so that's 9/6 take away 6, 9/6 take away 4/6, isn't it? 9/6 take away 4/6 is 5/6. 5x over 6. You can tap it in the calculator if you need to. Now we've got ninths here and quarters, so that's awkward. So we've got to use 36. 16 36ths plus, I'm going to use a calculator here so I don't have to keep it all in my head. So it's 4/9, so 4 divided by 9 minus 1 plus 9 over 4. 9 divided by 4 equals 61 over 36. So we've got plus 61 over 36x squared. And then the x cubes, which are all down here. So let's use the calculator again. 8 over 27 with a minus. Minus 8 divided by 27. Plus 2/3. 2 divided by 3. Minus 3 over 2. 3 divided by 2. Plus 27 over 8. 27 divided by 8 equals 4. Looks a bit strange, doesn't it? Because we've only got thirds and 27ths, but there's an eighth here. Yeah, so it could well be that. So it's 485 over 216, and it's plus 485 over 216, and that was x cubed plus dot dot dot. So just do it by a 6. We've got a sixth of that. 5x over 36, and then we've got 61x squared over 6 times that, which is 216. Okay, and then we've got 485x cubed, which divides by 3 actually, doesn't it? Yeah, 485 over 216 divided by 6. We've got it in the calculator, so let's just divide that by 6. 485, oh there we are, over 1296. 485 over 1296, didn't divide by 6 or 3, over cubed, plus dot dot dot. So there's the series. What's the valid range? Well, here the 2x, well this one would be more restrictive, wouldn't it? So let's consider that. So we've got the modulus of 3x here. When we expanded that series, well we expanded this series, didn't we, really? And this one. So which one would be the more restrictive? It would be this one, wouldn't it? Because it's bigger. So when we flip it upside down, it's a smaller range. So that would be less than 1. So that tells us that x, when we move the inequality between 1 and minus 1, this will be 2/3. And less than minus 2/3. And saving space, I've just written down the range here that's valid.